Okay, good afternoon, everybody. I'm going to start the meeting right now. I think there must be something wrong with this grade 10 meeting because several people asked me how to connect to it, and I'm not showing anyone actually in the meeting right now. So I think something must be off in the way I'm doing this. I'm not a big fan of Microsoft Teams here. It's a little counterintuitive to how I would normally do this. Oh, here's someone wanting in. That's good. Okay, so maybe it is working. Not sure.
There you go.
So, anyways, so yeah, I realize a lot of people are having trouble connecting, but it's nice to see at least one of you are getting in on the meeting. That's great. Okay, so I'm just going to mute the participants there for now. Okay. Okay, so yeah, it's still a little tricky here. So anywho, I'm just going to continue with my plan. And as people want to join, they can join. And if people want to leave, they can leave. And if people want to ask questions, they can certainly ask questions. Okay, so I'm going to start by sharing my screen, which is probably what you want to see and not me. Okay, so from my website, from our courses website, I've now made a change, an update to each week. So this is week 11 right here, April 27th to May 1st. And the plan this week was to work on conditional statements, part 1 by now, and started part 2 by now. So in here I have links to all the conditional statements content that you need, and even for those who are ready to start looping part 1, I have connections to all the looping content in here right now. Okay, what I plan to do this week in this live video is to go over part 2 of the conditional statements unit. So that would include the third and fourth unit assessment of conditional statements. That's the plan. I will not be going over the case study. Everything you need to know about the case study is in the case study description. Last week, if you look here, in week 10, I went over part 1 of the conditional statements unit. So if you need to look at that, you can go back to the video from last week, and you can look at the content from that week, from week 10 back there. You can see here, if you go through it, it has all the content in there from last week and how to do conditional statements part 1 and 2, or assessment 1 and 2. It also has how to go through them from the alternative assessments point, and I'm hoping to do that with you guys again today as well. All right, so let's get started by looking at conditional statements assessment 3. I'll just have that open right now. And another thing that would be useful to go through with this would be to have the hints open as well. So to have the hints. Now I also assume if you're doing part 2 at this point, you have been through the videos or read the presentation for part 2, and you've done the second example. So I'm just going to open each of those up in turn. So this would be the presentation on the new content in part 2 of the conditional statements unit. So I would have assumed you've either read through this and or watched my video, which is a lot more detail of me delivering this lesson in the past for conditional statements part 2, where I go through all the content, and I'm just going to mute that, and I've also went through the example in this video. So it's a 47-minute video that you could scroll through at your own pace or watch the entire thing to get a feel for what it would have been like live in class. You can read through this to get the notes as well on this. And if you need as well, I also have a link directly to the example. So the code itself, which is right here, which includes the first example of an else if statement in C#. So that's all what you would need to prepare to start looking at this one, conditional statements problem 3, this little miniature database type program. Okay. In addition, you can also have the hints open. The hints would include code from that second example. I'll just sort of scroll to it right now. So it has all the other examples from variables to the first conditional statements. Right here, you can see this could be needed in problem 3 and 4. And then here as well, some stuff that you could get hints from for problem 3 and 4, which we're going to do today. All right, so let's start with problem 3. So I built pre-built design here, and I have pre-named, just take care of that, all the objects. So here you can see from btn enter all the way through all the labels, everything is pre-named here. Okay, let's do some of the easy stuff first. Let's do the exit button. Okay, the exit button, obviously, will exit the program also known as an app or an application. Okay, it's application.exit. This code was seen all the way back 2 units ago, but that's a real quick, easy way to get that done. Okay, and now that we're in the code, we're going to realize that in this particular problem, this is a good problem that makes use of something we learned in the variables unit called global variables. Global variables are made up here in the public partial class section. And this program really stores a ton of variables. It stores certainly all the total students, but also every student for every grade is stored here. And remember, global variables are needed in 2 ways. One, if it's needed in multiple places, like multiple buttons here. But in this problem, I think more importantly, where we need the global variables is so that they always remember their value. So that's what I'm going to do. I'm going to make an integer for the total students, and I'm just going to set it to be 0. Then I'm going to make an integer for the number of kindergarten students, and an integer for the number of grade 1 students. Now, I certainly could type out the entire grade word and the entire kindergarten word here. That would be definitely better. In general, in computer science, it's better to be a little bit lengthier with your variable names. But for the purposes of time here, I'm going to use more of a sort of a math style of naming. So grade 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And I'm just going to go in and make some changes to these, to these numbers. I realize I'm going quite quickly. So there we go. There's all 12 grades and kindergarten, so 13 grades, and 1 to store the total. Okay, back to the design. Obviously, most of this code comes when I click the enter button. Okay, so what's the first thing I'm going to need to do? I'm going to have to read, whoops, not feed, it works too. Read from the text box and convert to a number. This is something we've been doing. So a string of text equals txt age dot text. You'll also find if you were reading through the second presentation or watching the video, okay, oh, that's the hints. Let's go back to some of those hints. There we go. That in addition to in the second one, looking at things like random numbers, which is a little, and then there's something called form load. There's also some interesting little extra tips in part 2, like these logical and, or, and not operators. And then the second example, which kicks in after that, right? So those are definitely things that you could start trying in your code. It isn't necessarily specifically connected to conditional statements, but it's just something to start thinking about. All right, now the age of our student. So I'm going to make an integer to represent their age. Don't really need any decimals in this problem. So I'm going to convert to an integer that text that I got out of the text box. Okay, we often use the word value here as well. Text is okay as well. The only thing I worry about with text is I have seen students accidentally put a capital there, and that actually means something very different. So that's why I usually recommend, instead of text, actually calling your variable value, the value out of that text box. Now it's an integer. Okay, now I got to check that age. In the problem itself, it does state that if they have an age that's younger than 5 or older than 17, we're going to display a message box. So I'm going to code that first. Okay, if age less than 5. Part 1 of this unit, we learned how to create a if statement, which uses both curly brackets, round brackets, and a little test in the middle that uses a logical operator like less than, greater than, etc., to check to see if one side tests with the other side. If this is true, then it runs the code right here. So if it was true, I would be putting up a message box. It would be showing in that message box the words, "Are you not too young?" Something of that sort. And at this point, I could actually test just that alone. I could type a number that is in fact less than 5, and let's see if that message box appears. I could also put a number that's greater than or equal to 5 and make sure the message box does not appear. This would be a quick test to make sure the if statement I wrote is working. So there it's saying, "Are you not too young for school?" And if I put in a 6, nothing appears. So it seems to be working the way we expected it to be. All right, now I'm going to put in what's called an else if statement. Else if is something, again, you can read about and watch the more formal video in part 2 of what it means, and it's a way to use multiple conditions. In other words, anything more than true and false. So if it's an age greater than 17, copy paste here. I'm going to also display a message box saying, "Should you have not graduated by now?" And I could certainly test that as well, but I think I'll just leave that code as is. So if they're less than 5, if they're greater than 17. The key with this problem, though, is the first use of the else if code, where it checks one and then it checks the other. We don't want to use separate if statements for each of those, because that ends up slowing down the code. We end up connecting them through else if. And now I'm going to go through every age. The age is 5. So according to the problem itself, the age of 5 indicates that this is a person in kindergarten. So what I'm going to do is I'm going to take my kindergarten variable and I'm going to say it's equal to itself plus 1. So this increases the age by 1 by adding it onto itself. Further on, later on, I'm going to show the variables in the labels. So I have a bunch of labels. For example, I have an LBL kindergarten dot text equals. So I'm going to put some words in there, and then that variable kindergarten, or K. And the words I'm going to put in there are the same words that are in there right now. And since I'm not a huge typist, I'm just going to steal a little of that and put it right there. The number of students in kindergarten equals, and then it's going to attach that variable. Let's actually test that. So let's test what happens if I put a 5-year-old into this database. 5, enter. There it now shows a 1. If I keep entering 5s, the number keeps going up. Perfect. Then what I would do is I would repeat this else if with the age of 6 for grade 1. Grade 1 equals grade 1 plus 1. Similarly, LBL grade 1 dot text will be equal to, I will attach grade 1 to this. And what I'll put in there to start will be the exact same code, or the exact same words, pardon me, that appeared right here. Now, this problem is essentially, for the most part, done, except I'd need grade 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that was a lot of copy paste, but let's go in and change all these. So at the age of 7, grade 2 would go up by 1. Age of 8, grade 3 would go up by 1. The age of 9, grade 4 would go up by 1. I'm going to pause here for a second. For those of you who are feeling like you want to take on a bit of an extra challenge, if you were to read through the notes or watch the video, there are some extra things that I talk about in part 2. For example, if you're feeling a little more confident now about the code you write, there is an example here of how you could start to omit curly brackets when the line of code is one line. That's the case right here. We're just doing, for example, this message box is just one line of code. This message box is just one line of code. So in a way, I could, and I'm going to put a few extra spaces in, just use the message box code itself. And I'm going to do that. Just to shorten this code up a little bit. I don't really recommend this. This would be, again, for those of you who are feeling pretty confident in your code at this point. Okay. I'll do one more. Back to cut and paste. Okay, so I'm just going to get rid of all the code we had up to here and zoom in. So here you can see the age is 5, kindergarten equals kindergarten plus 1, grade 1, grade 2, grade 3, grade 4, and I could keep on going if I want. So now the age, grade 5, 6, 7, 8, 9, 10, 11, 12. So, and now I can go through and kind of do this a little bit faster. I don't really recommend this. What I actually recommend is you guys go back to the curly bracket style that I'd previously shown you. I'm just doing this for speed right now. And then this would be 5, 6, etc. Okay, so that's a quick, and you got to make sure you do this in all the right places. It's easy to make a mistake here when you do a lot of copy paste to forget a little piece of what you've been doing. Okay. So there you can see the entire if statement from age 5 greater than 17 all the way up to the ages that equal all the way up to 17, which variable it changes. And then obviously I'm going to have to do all these labels as well. Grade 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Bear with me as I go and make some changes here. Okay, more changes to make. So in a lot of ways, this problem is, I think, the easiest one in the whole unit. It's definitely the longest one, but it's mostly just repetitive. It's a repetitive thing. So it's a matter of sort of really watching your code and making sure you're being diligent about exactly what you're doing as you go in and do all this. Now, there is one other thing to do in this problem, but before I go any further and finish up that last piece, let's just sort of test all this. We can certainly test each one, but I think we'll just do a couple different ones to test. So an age of 6, an age of 8, a couple ages of 8, age of 15. You can see there it's changing different variables depending on that age right there, which is good. Okay. Finally, we need to know the total. We're going to calculate that total. Let the computer do the math. So total equals kindergarten 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if I can add up all those grades, to get a total. That's one way to do it. There are other ways. You could certainly also put that in your if statements. You're not going to get marked wrong for that. This is one solution to this problem. Oops, could I add? There we go. And then similarly, that label will also be updated. The total label will include the total on there. And its label will say what it says right here. Is my friend. And let's see how that works now. All right, so 13 into the database, few 13-year-olds, 4-year-old, too young, okay, doesn't change things. A 6-year-old into the database, and the totals are changing. So it looks good. Final thing to work on would be the reset button, obviously. With reset, I have to first reset the variables. Then I have to reset the labels. Well, the label part is easy, because I've already got the code right here for how I'm going to put the stuff into the labels. So I'm just going to copy that, paste it. I don't need to recalculate a total. I just need to display what the total is. But to reset the variables, what I'm doing is setting them back to the starting point, in other words, 0. So grade 1 has to go to 0. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the total has to go back to 0. So again, a monotonous problem, very repetitive as coding can be, but hopefully again strengthens your idea of the if statement or the conditional statement, so that now with all that in place. Okay. Also, don't forget to do your general comment at the top. Don't forget about that. This program should now be fully functional and should be available for you guys to do it at a slower pace. Okay. And 13-year-olds entered. 16-year-olds entered. 8-year-olds entered. There's all that stuff entered into the database. Put a couple 5-year-olds in. I'm now going to reset the database, put a new 5-year-old in, and you can see all those numbers go back to 0. All right, that concludes that problem. I'm also going to show how that would be done through the alternatives assignment as well. So opening that up right now. And yeah, problem 3 is probably the longest problem, the longest one to deal with. So in the alternatives problems, for those of you who can't open Visual Studio normally, and by the way, the alternatives assessment now includes the looping unit. It's now added on there. But if you want to look at problem 3, as you can see right here, only enter 10 student ages. So you just keep entering student ages, and then it updates all those numbers. So it still has a lot of the same stuff. You just can't continually keep entering ages. Okay, so let's take a look at that one. I forgot to do this, opening up that website. So it can just work right off the online version of it. Okay. And make a new one. Still remembering all this stuff. Okay, so we're going to get the user inputs. We'll say to the user console. There we go. Page 1. We're going to do this 10 times, so be able to do some copy paste. And for age 1. Actually, let's just make one age variable. That would make a lot more sense. We'll make that first. And age equals, actually, no, we are going to equals, yep. Um, and then now we're going to need all the other variables, the different ones there, okay? Because if age equals, and since we're not converting it to a number, we certainly could, but I'm just going to say, actually, no, we should do that. No, I just realized that. Let's make that input variable age equals convert to an integer. Okay, so now that we have int age, okay, now we can use basically the exact same code we did here to update the variables. So I'm going to take all of these variables, total, kindergarten, etc., put them in this version, so it also has the same variables, total, kindergarten. And then I'm going to steal this as well, this if statement as well. And pop that in. The only thing that will be different is we can't be using message box with this. So instead, we'll be using console.writeLine to write out, aren't you too young? Or shouldn't you have graduated already? Okay. Then, unfortunately, because of the nature of this program, this will all need to repeat itself again. So all of this code to get a user input will then repeat itself for age 2. Okay. And then it will repeat itself for age 3. Okay. So that's how you can enter all those ages and then check them all. And then, very much like this one, you can update and calculate totals. Remember, you won't be writing a reset button in this program, but I'll be doing this, something like this anyways. Show the various labels, but not in labels, but instead I'll be using console WriteLine here to write it out. This. It's a very repetitive program to do it this way. A little bit easier to do it in Visual Studio itself, but certainly not impossible to do it this way, just because of the nature of the way this is working. Almost there. Round brackets at the end here. Don't worry, the last problem 4 is actually not as long. There we go. And then the total, also done, and also displayed in a console.WriteLine. Okay, so that's how it would go, something like this. Let's just try it out. So the first age will be 15, second age will be 8, and the third age will be 4. And as you can see, are you not too young for school? But then it goes through and displays that at 1 student in grade 3, 1 student in grade 10 for a total of 2 students. So it worked, okay? And that's how you complete from the alternatives assignments problem 3. And now we're going to move on to problem 4, the final problem of the conditional statements unit. Okay, let me just pause that for a sec and go back to me. Yeah, or no, I guess I will go back to sharing. Oops. So now what we're going to do is take a look at this final problem, one of my favorites, this slot machine problem. For this one, to do this one, there's a couple things from the second presentation that would be useful to you. One would definitely be the use of random numbers, obviously, to make it sort of a slot machine. But also, although it's said it's optional for sure, these logical and or not operators are going to be very useful to sort of optimizing our code in this problem. If you saw them being used in this second example, which they are used, for example, right here, the and the or, you would also see in the hints that it does also say that and or would be very useful to you in problem 4 of this unit. So it's right in the hints as well. So let's get started with that one. So I'm just going to open up conditional statements problem 4. Okay. Don't really have a lot of buttons to code here, just the pull button. So we'll get right to that. Right before we get to that, we're going to add in at least one global variable. This global variable will be used to store the amount of tokens that we have. In this case, I'm going to set it to be 100 tokens, which is also seen right here. Another thing I can code in this problem, although it's not completely necessary, is I can find a small piece of the form and double click it to code form load. Now I could set the global variable to 100 again, and my label for the tokens also change. Now remember, form load means that's the code that runs right as the form appears or loads. And so you can see that code is executed already as we're starting to see this. Okay. Now I want that to be a global variable so it always remembers how many tokens we have. Now I'm going to get into the logic of the pull button. I'm going to create 3 random numbers. Okay. Random new random is the line of code I taught you to use in part 2. Okay, this could also actually be a global variable. Okay, it is entirely possible to make random a global variable. Okay, and then what I'm going to do is I'm going to make slot 1 equal to random dot next. And it's a random number between 1 and 3, and we always go one more, so it's 1, 4. And I'm going to do that for the other 2 slots as well, slot 2, slot 3. And then I'm going to show in the labels. BL slot 1 equals, I don't want to really put anything in there, but I want that number slot 1 in there. If I do that with slot 1, I can do that with 2 and 3 as well. Okay, so let's just try it to this point. I've created 3 random numbers, and I've shown them in the labels. And I know I went pretty quick there, so if this is again confusing to you, you should be either watching that video of me teaching this in the past, where I do go through a whole section on random numbers, and sort of go through how they work and different parts of them and things like form load. And there you can see that in the example where I talk about it and how it works. Or read through. But anyways, let's give this slot machine a shot here. Pull, pull, pull. There we go. We're getting random numbers every time I pull. I'm also going to take a token away. Tokens -1, and I'm going to display that in the label the same way I did right here. So the user can see that they've lost a token for playing this slot. So let's try it again. Pull, pull. So there the tokens keeps going down each time I pull. The final piece of this problem is to check winner. And the check is the if statement. If. So I'm going to check to see if slot 1 equals a 1. And slot 2 equals a 1. And slot equals a 1. If all three of those equal a 1, then we have a winner. So I'm going to put up a message box. Show that, whoops, you win all ones. One with all ones. In addition, the tokens goes up. Tokens equals tokens plus, according to the assignment sheet, although you could certainly change it, it wouldn't be a big deal. But whoops, close that one. It says here if they get all ones, they get 4 tokens, 8 for all 2s, and 12 for all 3s. So all ones is 4 tokens. So I'm going to add 4 tokens to what they get. Now what would make a little more sense is this line here where I display how many tokens they get. I'm going to do that later in my code, not so early in my code. But I'm going to display the tokens. Any changes to the tokens later on in my code. Now, that's how you get a 1, 1, and 1 to win all 4. What else if the slot 1 was a 2, a 2, and a 2, and I win for all 2s, I win 8 tokens. So here's another use of else if, and also the combination with the and symbol there. And then finally, what if I get all 3s? If I win all 3s, I win 12 tokens. And then there's one other little piece to this. I want to check for game over, because if the tokens less than or equal to 0, then they don't have any tokens left. So message box, oh, it's game over. And at that point, I can actually shut down the program as well. I know how to write a line of code to do that. Okay, so this program actually doesn't require as much code, okay, as the previous one. Went actually a lot faster. I'd say in a lot of ways probably the least amount of code of almost the whole unit. But let's just see if it all works now for this slot machine. So, question?
Can you see?
I can hear you. Just going back to Microsoft Teams for a sec. Whoop. I see you guys are there. So, okay. So I'm going to go back to sharing my screen just to finish up this problem. So here we go. I'm going to keep pulling. And you can see here, I keep losing. Oh, they're all 2s. I win. You can see there it went up by 8 tokens. I keep pulling, keep playing slot machines, all 3s. So you should see this go up by 12 tokens. And I'm just going to hold down this and keep playing here for a while, try and get this all the way down to 0, which might take a minute or two because I'm pretty good at gambling. I just recorded that. I think I did. All right. Down again. Nope. Keep winning. Come on, get there. Nope. Keep winning. We're going to lose. The odds in our game are much better than in real life. Okay, here we go. Getting down there. Oh, here we go. Nope. 5, 4, 3, 2, 1. Game over. So that works too. So that shows all the code for that one. I'm going to wrap today's class by now showing how I would do that problem as well in the alternative assignments, for those of you doing the alternative assignments. I'm going to do that as well. So for those of you doing the alternative assignments on the website, And now you're going to look at conditional statements, problem 4, okay? You can see here, in a lot of ways it works very similarly. Welcome to slot machines. It says it doesn't need to keep track of tokens though. All it needs to do is play once and decide whether you win or lose and how many tokens, but it doesn't need to track how many tokens. So let's do that. Yeah, I'm just going to erase the code we had from the previous one, which was really long. Okay. And so in a sense, the alternatives assignments, you'd really only be programming very much like just the pull button. So you'd be making something random. Pop that in there, making something random. Then, like the pull button, you'd create 3 random numbers. You would show them and take a token away, except the showing part would be different. Instead of showing them in a label, we need to take a token away. I forgot we're not dealing with tokens. Instead, what we'd be doing is the console dot write line, displaying that like that. So we might as well say slot 1 equals. So that will look a lot nicer when we show it. And we're going to test that right away here in a second. Slot 2 and slot 3. Okay, so let's just run that. There we go. Slot 1, slot 2, slot 3. 3, 2, 3. 3, 3, 3. 3, 3, 2. 2, 2, 3, etc. So that's how that would work. And then we would check for winners the same way, okay, and display the change. But we don't need to worry about tokens. So let's just put it in. Check for a winner. Except instead of a message box, we'll be doing a console write line right here. All 1s you win. We again don't need to deal with tokens in the alternative version. We just write out all win. All win. And you know what I'm going to put in for this one, since we're not dealing with tokens? I'm just going to put in a console write line saying you lose, because we want to see if we win or lose in these slots. So let's try that. You lose. You lose. You lose. You lose. You lose. Okay, so it is still a slot machine telling you if you win or lose. I seem to be losing a lot here, but it is possible to win. It is random. I'm going to keep doing this until I win. There we go. All 2s, I win. So this would be, don't forget your comments, the alternative version of conditional statements problem 4. Okay, that was our goal for this week. Our goal for here in this online class for week 11 was to go over part 2 of the conditional statements unit. And I've done that. I've gone over both of these problems, both in Visual Studio and the alternative version on the website. I know I went pretty quickly, so you can go back in this video and rewatch sections if you'd like. What I, of course, recommend is you actually go in and watch the actual class lessons of me teaching this, do the actual example, just to go over what's up for next week. Next week during our online class, what I hope to do, and I've updated the entire calendar for every week, is I'm going to go over part 1 of the looping unit next week. And then the following week, part 2 of the looping unit. So that's the plan at this point. I'm also open to questions and comments during these live classes, or you can email me at any time with questions and comments. And finally, the last thing I have to say will be that hopefully after this week, I'm going to start posting, and I'll send out emails about this, some inspirational videos for you guys from former students who want to give you guys some advice on why it's a good idea to continue studying in computer science. I have one of them right now. I'm just going to play you a little bit because it's very short, just to give you a feel for it.
Hey guys, my name's Jack. I graduated from Surgeon Heights in 2015.
Okay. Okay, everybody. So unless there's any questions, and I'll give those of you on the line right now a chance to ask if you have them. That's going to be our online class for today.
What happens if you're behind on anything? Like, let's say